Assalamu alaikum and welcome to part number 5. Maybe the second last part for this series, or maybe as this goes on, we can do a lot of other algorithms, specifically when we are going to go towards functions and a lot of other stuff. Today, we are actually discussing the Armstrong number, and that Armstrong number is this thing. And just to, make it a little easy, so let's just copy this Armstrong number and see what is an Armstrong number first. So if I have an Armstrong number, let me just increase this a little. So an Armstrong number is that number. It's also called as a narcissistic number. It's a positive integer whose sum or is equal to the sum of its own digit, each raised to the power of the total number of digits. Now, this is a very heavy mathematical term, but anyway, I will try to explain this here. What does this mean? It's a positive number, so negative numbers are not allowed. So this is one check you have to do in your code, that it's not going to take any negative number input. And it's going to be equal to the sum. So this means there is going to be something summing up. So there is going to be some positive sign addition over there. So the sum of its own digits, each raised to the power. Raised means that you are actually going to have x raised to power y. This is actually that raised thing. Or actually you can call it like 2 raised to power 3 or 3 raised to power 3 or 4 raised to power 4 or something like that. So you are actually going to have some summing up of some entity, something like this. So x raised to power y plus a raised to power b plus c raised to power d, something like that. So it's going to be something this one. They have also given an example that 153 is an Armstrong number. How? So 153 is an Armstrong number because you are actually going to have a sum of 1, 3. So 153 is actually going to be 1 raised to power 3 plus 5 raised to power 3 plus 3 raised to power 3. And if you open this one, this is going to be 1, this is going to be 5 into 5, 25 into 5, this will be 125, and this will be equal to 27. And if you do that, that is equal to 153, and this is okay. So this means that this is an Armstrong number. This is actually definition. If this was not equal to, then of course, then this would have been not an Armstrong number. Another example is actually a 360 number. Now let's see, first of all, let me just use it and how we are actually going to find it out. Now let's just take the example of this thing that you have a number, let's supposedly 1, 5, and 3. And based on this number, that number is going to be stored somewhere in some input, supposedly. First of all, let's see, before developing the algorithm, we need to first of all see what we need actually to find out this thing. If there's a number 153, first of all, what you need to find out, you have to check on the first thing, that you have to store this inside a variable. You have to store in a variable. And supposedly that variable here is going to be, you can call it a number or numbr or something like that. You can, whatever the name of the variable, totally up to you. Next thing over here, you have to check it on that your number numbr is greater than 0. This is something very important. Then you are going to proceed further. Otherwise, you are going to just display that it's not an Armstrong number, because negative numbers can't be. So this is the first condition. So proceed further. Otherwise, the answer for this is that otherwise, maybe just print it's not an Armstrong number. Not an Armstrong number. Next, if you are going to proceed and if it's a positive number, if you see over there, whenever you are talking about this 153 over there, the first thing you need to find out, you need to separate this. You have to separate 1, you have to separate 5, you have to separate 3. So this means you need to have 1, you need to have 5, you need to have 3. And at the very same time, you need to find out this power of this raising. And what is this? This is actually the number of terms in your number. How many digits you have. So here, if it's a 3-digit number, then it's going to be 3. So next thing which you have to do is find the number of digits in your number. And when you have done it, now how you are going to do it, now we'll talk about this one. This is a mathematical thing, how you're going to find it out, because this is going to be something. So yeah, when you found it out, supposingly, and you have found it out and you have saved it inside something, a number n, supposingly, you can call it n over there or n o or something like that, whatever you have done it. When you have found it out, how, we will just discuss later on, or maybe on the next page I will do it. When you're going to, when you have done it, then next thing, very importantly, find the individual digits. You have the find the individual digits. So for example, if the number is 153, you get 1, you get 5, you get 3. If it is something like, supposedly, let's say if it is 1 2 3 4, then you get 1 2 3 4. So you are going to get this over here. Now when you have found this all over here, supposedly, when you have found this individual digits, now what you are going to do here, take each digit, you have to take each digit, raise it and raise it to what? This one, that is NO. Or let's just say, don't call it NO, because NO means actually no, so I'm just going to raise it to N. So what this means, supposingly, just for example, let me just give you, instead of 153, I have 3 numbers. I'm assuming it's a 3 digit number over there. I'm calling this as X, I'm calling this as Y and Z, just to make it a generic in front of you. So what is going to do, you're going to have X raised to power N, sum, in fact, let me sum all digits raised over there. What does mean over there? Yet you have to do X raised to power N plus Y raised to power N plus Z raised to power N. And you are going to call this one over here, let's say you're going to sum all these together over there, and let's say you call it as the result. And when you have done this thing, the next step, which is something which is the last thing, when you have got all this, I've summed it over there, compare your result with the number, and if both are equal, then print Armstrong number, else print not an Armstrong number. Sorry about the writing, I don't have much space, so that's why. So I hope you are now getting what is being done. Now here in this hall, let me just repeat this all. You are taking an input from the user. Let's say it's 153 or whatever, it's something XYZ or something like that, whatever. You're going to store it inside a variable number. You have a number, check it, it's greater than 0. Of course, if it's greater than 0, then you can proceed further. Otherwise, just print it. It's not an Armstrong number. Your whole program don't need to run it. Third thing, find the number of digits in the number. And this is actually a mathematical algorithm now. I'm just going to do it over there, the third one. Fourth one, find the individual digits. Again, you have to do some division algorithm over there. So this is something, again, you are having an integer, so of course you have to find out 1, 5 and 3. And this is something very, very important. Whenever a 3 digit, 4 digit, 5 digit or 6 digit or whatever number is being input over there, you have to find it out, the number of digits and individual digits as well. Then the next thing is, something is very easy, which is just the raise it to n, which means that you have 1 2 3 4 or maybe XYZ. You are raising it to X raised to power N plus Y raised to power N plus Z raised to power N. Add all these together and store it inside some variable, of course a temporary variable result. compare it with the original number that was input by the user. If they both are equal, this means it's an Armstrong number, otherwise it's not. Very simple. Now, let's see. I'm just going to give you, I'm not going to develop the whole code here today. I guess you are not familiar how you're going to do it. Again, here, this is not going to be for loop. Remember, for loop runs for a specified time, a specified number of iterations. Here, let's just see first of all, if you have found out if this condition is something very easily, you can use it by if else statement. This is just by scanf. This is just by the greater than 0 if else statement over there. This thing, find the number of digits in the number. Now this is something very, very important. So I'm now going to do this third thing, which is how you are going to find out. Let me just add this over there. And I have this third one, which is actually the number of digits, how you are going to find out the number of digits. Now remember, whenever you are going to find out the number of digits over there, and that is the question over there, you have the original number stored inside this variable number. Now, since I am going to do something with this variable, so it will be better to make a copy of this number and make it something, a copy of it. Let's call it, let's just call it original number, or number underscore copy or something. Why? Because when I'm going to work on this number over there, the number will be, the variable will be having a value change over there. So I'm going to save this number and work on this original number over there. That is going to be called as, let me just call it a variable. In fact, let me use a variable which I'm going to use or show you the code actually. So this will be original number over here. So when I have this variable, so what I'm going to do now, when you have a number, supposedly 153, I want to count this. I have a number 153, supposedly. If I want to count how many numbers, supposedly I divide it by 10. What is going to be the answer? Of course, I'm going to divide it by 15. So this will be 150. Remember, this is integer division. It's not going to be floating point, because the compiler is, unless and until you are using some floating point library over there, we are not using. So the remainder is 3. So what happens? The answer is there. You have 15 quotient, 3 is the remainder over there. Now what is done? Again, divide the quotient by 10. This time you are going to have 1 over there. So this time you are going to have 10 and the remainder is going to be 5. And similarly, now this time divide again by the quotient over there, and this time it's going to be 0 over there, and the quotient is going to, remainder is going to be 1 over there. Oh, sorry, I have done it wrong. So this will be 0 and answer will be there. And what are the 3 quotients here in this thing? The 3 quotients are 15, 1, oh, sorry, not 15, sorry, the quotients are over here. What do you want this? The quotients are 15, the quotients are here 50, over here the 1 and then the 0. And what are the remainders? The remainders are this thing, 3, 5 and 1. And what are 3, 5, 1? They are the digits. So practically, whenever you are going to divide it, you are actually going to have the digits as well. And how many times you have to do this division? You are doing it 1, 2, 3. So this means that you are actually going to divide it and increase a variable, and that is actually going to tell you, okay, the number of digits on it. So very simply here, you are actually going to use the while loop. So while loop, and inside it, the number is, supposedly, I have saved that number inside our variable, which is going to be called as original number. That original number is not equal to 0, which means this thing, quotient, because if I do another division, I have to divide it by, I have to divide 0 by 10 over there. And inside this loop, what I'm going to do, now this is actually something very, very interesting. If you can see over there, you have original number not equal to 0, and you have original number equal to original number divided by 10. So what you are doing over there, whatever that number is, 153, you divide it by 10, the same thing which is being done over there. you get the quotient, that is 15. You store that quotient inside original number, because next time you are going to divide 15 by 10. Then if you get the quotient 1, you are going to divide 1 by 10. So you are going to repeat this, and inside this thing you are actually going to have your number being increased, which is going to be n over there, which is actually this thing, and you are going to have your n increased. So every time this division takes place, you are going to have this thing increased over there, and when you are going to have this thing increased, just close the loop. So this all loop is going to work just to give you the number of digits. Now, even if you have a 4-digit number, supposingly, let's say, let me just take an example. Let me just rub this all and show you that if you have a 4-digit number, and that 4-digit number is going to be inside, supposingly, let's say that 4-digit number is 1, 2, 3, 4. That is inside your original number. Main number is saved. I am copied inside another variable. So if I'm going to divide this 1, 2, 3, 4 by 10, what is the answer? 1, 2, 3. So answer is 1, 2, 3, 0 over here, and the remainder is 4. Gone. So what is now the quotient? The quotient is 123. That quotient goes inside the main variable. So now what happens? N becomes equal to 1, because n was equal to 0. Of course, you have to initialize it to 0. Then you are going to divide 1, 2, 3 by 10. This time the quotient is 12. So this will be 1, 2, 0. Remainder is 3. Again, now again divide 12 over there, and this time it will be 10, and this will be 2. And the third time when you are going to divide it by 2, oh sorry, divide 10 by 10, the 2 over there, so this will be 0, and this will be 0, and the remainder will be this thing. So up till the quotient becomes equal to 0, because you are dividing again and again quotient by 10. Just to give you a little reminder, whenever you are dividing any number over there, remember all thing. This is the divisor, this is your quotient, this is your remainder, this is your remainder, this is your quotient, this is your divisor, and this one is your dividend, which you are dividing over there. So every time this of division happens, 1, 2, 3, 4, until the quotient becomes equal to 0, because this is the condition over there. So up till the condition is not fulfilled, or it's still there, the number is going to there, and at the end of this thing, the n variable is going to have your number. Now when you have got it, now original number at the end of this one would be equal to original number equal to 0. Okay? So if you want to now make it back to your original number after this thing, supposingly, let's say, then you can have, because your original number was stored inside this variable number. So here, after this third step over there, you want to bring back your original number. So you can just have original number equal to number. We just want to preserve, or we just want to bring back the original number. Why? Because now in the next step, we have to find out the individual digits, which are very important, and how you are going to find out 153. Now you may argue over here that you have already found out those remainders over there. You can do it by the remainder operator, but I'm not going to do that one over here. Why? Because the number of digits is the first thing, because you need to do some sum. You need to do some sum, plus you need to do the raise to the power. So you need this value. You need this n over there to find out that the digits have to be raised to what number. So you can't get 2 or 3 different quantities at the very same time. So the first thing, the third digit, you need to find out the number of digits. Now in the next step, when you are going to find out, the fourth step is going to be, that is, let me just go back and find the individual digits. Now you need to find out the individual digits. That is, find the individual digits. Now how you are going to do that? Because you don't know how many digits are always going to be there, because it can be 1, it can be 2, it can be 3, it can be 4, it can be 5, it can be. So same process, same condition like this, I'm going to divide it, but this time the division is not going to be this thing. It is going to be the remainder. I want the remainder to be there. Okay, I want the remainder to be there. Remember, this was a division operator. Why? Because if you had a number, supposedly 1 5, you are dividing it by 10 over there. What you get? You get one answer. But if you divide 1 5 by a percentage sign, you get the remainder 5. And 5 is what? 5 is the digit over there. And if you divide the 1 divided by, so you're going to get it again. So you need to find out the remainder. So here the point is that you need to find out the individual digits. Now when you need to find out the individual digits over there, this means that the term which you are going to get is, I'm again going to have a variable now, and that variable is going to be int remainder. Let's call it 0 at present, because that is going to be initialized to 0. And here I am going to have remainder equal to original number. Of course, this is going to be original number. Ten over there. So you have the modulus sign, the remainder operator, and you have it over there. So if you have any number, supposedly 153, you are dividing it by 10. So you are going to get the 3 value first. So this is 3 value coming on to everything. Now when you have got 3 over there, now remember this thing, when you have got 3 inside it, supposedly, because here it was 153 divided by 10, oh, sorry, not divided by 10, 153 remainder 10, what will be the answer? The answer would be 3. This 3 will go inside the remainder variable. Now when you have got 3 inside the remainder variable, what to do with it? Of course, what you have to do is it that you have to raise it to the power n, which means here you have got z over there, so you have to raise this 3 to remain 3 over there. So first thing first, after this remainder is done, which is you have got the remainder, you have to find out and you have to raise it to. Now you can raise it by using the power library from your math, but I'm not going to use that one. So for that purpose, what I'm going to do over there, see this very carefully, because now I need to find out the power over there. So for that purpose, I have to run a for loop. And inside this for loop, let's just say int I is equal to 0 and I is less than n and I plus plus. So what I'm doing over there inside this for loop, whatever number I have, remainder, and remainder multiplied by remainder multiplied by remainder multiplied by how many times I want to do it. And why I'm doing it n over there, this n is telling me that you have to multiply it by n times, the same number but n times. So for this purpose, I have to have a variable. Let's just call it, I am going to use another variable over here, int power equal to 1. Now why this is 1? Now this is something very tricky. See this one carefully. I'm not using the maths library. This is something different. So here I have power equal to power multiplied by remainder, and close this. You've got it. Now what is happening here? See this very carefully. We had a number 153. You had got the remainder from here 3. That 3 was inside this remainder variable. And now when this goes inside it, this is 3. I is the variable you are starting it. So this all loop is going to do 3 times. So what is going to happen? What is the value of power here? Power is 1. Remainder is 3. So 1 multiplied by 3, answer is 3. Then the next loop happens, 3 multiplied by 3, this happens, power becomes 9. Then the third time this loop happens, 9 multiplied by 3, and the answer is 27. So what is 27? 27 is actually the remainder raised to power 3, and that is 27. So what you have done actually, the remainder which you got from here is actually going to be raised to the number n. And what was n? N was the number of digits over there that you have found out from this particular while loop. This while loop is totally different. And I have not still said this as a while loop. I've just told you that I had a remainder and I had this thing and I have got it. So what is being done up till now? You have taken any number. Now again, I'm assuming it's a 3-digit number. It can be a 4-digit, it can be a 5-digit, 6-digit, 7-digit, totally up to you. But here, supposedly, this is a 153, and this one, you get an answer or remainder of 3. So now you are doing it 3 raised to power 3, and the answer is 27. So now what is this? You have got the last digit raised to power. So now you need to go for the next digit. Now you need to go to the next digit over there. So for that purpose, you have to save this power somewhere. You have to save this power somewhere over there. So let's say I have another variable. Let's say I have another variable, and let me call this one. Let me just use another variable over there, and let me call this one as result equal to 0. Another variable, result equal to 0, because what I have to do, I have to save this power, because I need to calculate the other power, which means I have just found out 153. Out of this 153, I raised the last digit to 3 and I have got 27. Now save this 27 inside this result and wait for 5 raised to power 3, and then also add it inside it, and then find out 1 raised to power 3 and also add it. So this means that practically now result is going to be equal to result plus power. So you have got result is equal to result plus power. Now when you have got it, now your answer which you are getting over here, this thing is there. Now you have got this thing. Now you need to do for this and do for this. So this means that now you have to do again this division over there. So this means you need to write it down again? No, I'm not going to do that, because I don't know how many times I have to do it. Because supposingly, if it was a 4-digit number, supposingly it was a 4-digit number A, B, C, D, supposingly, then I will have to, for a 4-digit number, A raised to power 4 plus B raised to power 4 plus C raised to power 4 plus D raised to power 4, this will be stored in the end result. So I don't know the number. What I know is that your number of digits I know, that is n. So I can run this thing for 4 times. I know n. So I can have a for loop over there, and I can do that one over there. Or there is one other way that I can make this thing having a while loop, and this while loop is going to run till my original number is not equal to 0. And why not equal to 0? With this brackets open. And why not equal to 0? Because here I'm going to do, because now I need to repeat this from here. Whatever, I want to go back over there and now do this division, the remainder operator again. So this time, previously it was 153 by this. What I got 3 answer. Now what I have to do, I have to divide 15 remainder by 10. So this means that whatever the answer is 15, now I have to replace it with the original number. So this means that now my original number here is going to be equal to the original number divided by 10. So what I'm doing over here, that original number is already 153. When I came inside it, it was 153. I divided it by this thing. I got the remainder as 3. I did all the calculations up till here. Well and good, no problem. But now this time I don't need 153. I need only 15. So I will do 153 divided by 10. And since this is integer division, the answer will be 15. So this 15 will be stored inside original number. And from this original number, this will again go here. So this means that now I just need to close this thing. That's all. This is the main while loop. And this will run up till the time that this original number is not. And why this will happen? Because let's say, for example, I entered this loop with 153 and knowing that n was equal to 3. Okay? So when I entered this thing, the first calculation I did was 153 with this modulus 10. What I got? I got 3 in remainder. So I got 3 over here. So I did this for loop and I got 27. I added this 27 inside the result. Well and good, no problem. Then I went up till here, 153 divided by 10, I got 15 answer. I went back to this point and I found out, okay, it's still not equal to 0. So this time now I'm going to do 15 by 10. What is going to be the remainder? Remainder is going to be 5. Now when I'm going to use this 5, I'm going to again calculate the power of 5 raised to the power 3. So this time it will be 125. This 125 will be added to the power. So this means 27 plus 125 will be done. Now when I will go back over here, I will have 15 divided by 10. The answer would be 1. Okay, the quotient, not the remainder, because this is division of. Now this one will go back over here, and now this time this will be 1 to 10. What will be the remainder? Remainder will be 1. Now when 1 will go over there, 1 will be raised to power 3, and this will be equal to 1. So this means 1 plus this 27 plus 125, this all will be added inside this result variable, and when this will come over here, when I will do this 1 divided by 10, that remainder would be 0, because this time it's going to be 0 over there. So when it's going to be, this loop will be finished over there, and this will only run 3 times. Now this is one way. Another way is this, that instead of doing this thing, you run it for, let's say int k, int j is equal to 0, int j less than n over there, and j plus plus. So this will automatically just run for 3 times, or whatever the number of digits. This is one way of doing it. You can do this one as well, totally up to you. Now, when this while loop is done, at the end of this while loop, your original number will, of course, will be 0, because this condition is always going to be only running when it's going to be 0. Then, of course, it's going to be there. The result will be having 1 raised to power 3 plus 5 raised to power 3 plus 3 raised to power 3, and this will be the result variable. Now, when you have done this thing, the last thing to do is that you are going to compare this result with what? You are going to compare this one with the original number which we have stored inside and already saved it, because you needed it at the end. So you are just going to do a comparison over there, and that comparison would be, let me just in fact make this a little above so I have a space. So you are just going to do it if your result is equal to number, then printf, this is, you can call it, use the percentage %d sign, the format specifier is an Armstrong number. Else printf, your percentage %d, that is the format specifier, is not an Armstrong number. Over there. So I hope now you have got this point. So this is the only thing, and afterwards you can just do the return 0, and that will be the end of your program. So this thing is not just doing the 4, it's also doing 4, 5, and 6 actually. This is not just doing 4, it's doing the 5 plus 6 over there, and the conditioning is being done by this 7, which is actually the condition that it's a number. Now let me just show you the code here in front of you. I have the code here, and please try to develop the algorithm first, since I have to show you the code. That's why I have made the algorithm, the code first. So let me just show you the, okay. If you see over here, let's just see over there. In fact, let me just show you. Very simply, used a very different variable. You have the original number is this. This is the original number. This is the remainder variable. All the initializations are done in the top. On the contrary, I had done it somewhere here, so it's totally up to you. But I'm doing it in this code over here. You're just taking the scan of code. You're just asking the user, enter a positive integer, Then here, this is an Armstrong number. If number is less than 0, of course, negative numbers are not allowed. So it's not going to be a it's not going to be an Armstrong number if it is negative. Then afterwards, you are saving your number inside your original number over there. This is the number. I have used actually NUMBER. Here he is using number over there, num only so over there. So this is NUM and original number. They both are exactly the same. So they are just having the copy. Here you are calculating the number of digits, you can see over there. So while original number is not equal to 0, original number divided by equal to, this is exactly the same. I hope you are getting the point. This thing, this thing, original number is equal to original number divided by 10. So these both are, this thing and this thing, they both are exactly the same thing. So nothing. And here, this is the pre-increment operator. You can even have n plus plus, totally up to you. There will be no difference over there because this will be always running when this condition is fulfilled. When afterwards, every time the original number is changed, so this will be running. So if you have a number 153, you are dividing it by 10, dividing it by 10 every time. Why 10? Because 10 is the number of digits inside decimal number system. So these are the decimal number, so that's why you are dividing it by 10 over there. So you have number something like 263, you are going to divide it by 10, so this will be 3 times division, so n would be equal to 3. Then afterwards, resetting the original number. Of course, you are going to back it back because the original number has changed over there. Why I'm using the original number over here? Because the number is the original number and I need to keep it because I need to compare at the very end. Then afterwards, if you see over there, then the same while loop, this is the while loop over there, you can see the while loop over there. And inside while loop, again, instead of while loop, you can use the for loop as well. As I told you, instead of this while loop, you can use the for loop. Int j equal to 0, j less than equal to n, and j plus plus. This will, why? Because this will run for 3 times, because n is equal to 3 if the number of digits are 3. If it is 4, it will run for 4. So here you can have it on for instead of while. But here, while, I just give you an idea that while loop is actually also a very good loop, and it's a conditional loop, and it can run for an unidentified number of iterations depending upon whatever condition you have. So here you have the int power equal to 0. Now remember one thing, this int power is going to be equal to 1 inside the loop. Why? Because here this is being multiplied. So you are having power 1 multiplied by whatever the number, 3 multiplied by 3 multiplied by 3. So you get actually 27. Remember, never make this equal to 0, because if you make this equal to 0, then the answer will be always be 0, because you are actually taking 3 times or whatever the number of digits are. So if you have 5, so it will be 5 multiplied by 5 multiplied by 5, depending upon if the number of digits are. Otherwise, if you don't want to use this thing, then you will have to use the power function inside your library, where you have power into x comma y. This gives you that power function. Kindly try to do this thing also, because using the math.h library, that you can use the power function inside your math library or math.h. For that purpose, on the very start, you will have to include math dot h on the very start over there. Then coming back to over here, when you have done it, you have found out this one, so you are just going to add your result every time. So result is that actually number, so result is going to be result plus power. So every time you are getting 27, that is going to be added over there. Then you are going to get supposedly 125, or then plus, I'm talking about 153 over here, because 1 raised to power 3 is equal to 1, 5 raised to power 3 is equal to 125, 3 raised to power 3 is equal to 27. So you're getting add all these things and it putting them inside result. So when you have got this into result, then you need to repeat this loop. So that's why you are changing the original number. That's the same thing which I was doing. So this is original number divided by 10 over there. And when you have completed this loop 3 times over there, then of course you are going to compare your number with the original number, which is already inside the variable num, and you are going to print it. It's an Armstrong number, else it's not an Armstrong number. And this code is generic. This is not just going to run for like 3 digits number. It's also going to run for 2 digits. It's also going to run for 4 digits, 5 digits, 6 digits over there. Try to make this program and try to run this thing on your own computers, on your own compiler, so that you have an idea that how you are actually going to use. And this is actually a very classical example of how a while loop can be run. And try to change this code over there to a for loop and see It will still give you the same results, no issues in that one. I just use the while loop because I have not used the while loop in this all up till now. So this is the Armstrong number algorithm, and I hope you have an idea what I have used over there, the Armstrong number. And that Armstrong number, you can plug in your numbers as 370, 371, 407, and 9474. So 9474 is a 4-digit number, so you can do it and find out that it's an Armstrong number or not. I hope you have liked it and you have understood what I have tried to do over there, a while loop, and this is not some pattern printing. It is something very different, which is a while loop based on some number. You need to find out the number of digits. Remember, this number of digits thing which I've done over there is very, very useful, because sometimes you are going to ask a user a 2-digit, a 3-digit, or a 4-digit number. Then you have to check on that your number of digits is 2, 3, 4, 5, whatever. So this is going to be very, very helpful in your future coding, where you want to find out the number of digits of your number that has been entered over there. Plus, if you want to do some repetitive division, then this is also very, very important. Thank you, and Allah Hafiz.